In this video, we are going to go over some practice questions from logarithms. Okay, so if you want to understand the basic laws of logarithms, watch the video with the tag showing on top. Just click on it and you get to that video. For this one, we're just going to look at some practice problems to help you understand more in details. Okay, so question 1. Given that y is equal to log 3 x, find expressions in terms of y for log 3 x over 9. So in this case, this app couldn't show the base, so basically y is equal to log 3 then x. So 3 is our base. So for a, we are told to show in terms of y, so we have log 3 then basically you have x over 9. So we are expected to show this in terms of what? In terms of y. So we can split it. What do we know? So whenever you are dividing, the basic idea of the logarithm's laws is you can split this. So it can be log 3 x. Then whenever you are dividing, it shows that you are subtracting individual logs. So that's the way it gets to come out. Okay. And I believe we understand that in this case, what we have is y is equal to that. So if we know that y is equal to that, then this basically can come out to be y minus, so this part where is that, I've put y, then I've said y minus log 3. Then I can write the 9 in terms of 3, so it can be squared. So another logarithm rule tells us to say that, okay, so when you have a power 2, it can come as a coefficient of a log. So you have minus 2, then we have log 3, and a 3 there. So whenever you have got the same base with a digit there, that is equivalent to a 1. And what we have in this case, what is going to remain is basically y minus 2. So we simplify this. So this is basically equal to y minus 2. Okay, let's move. For the second part of the question, we've been given our b, which is basically log 3 then root of x. So I want to show it or express it in terms of y, where we know that y is equal to log base 3x. So this is the same as log 3, then x, the root of x is the same as x to the power 1 over 2. So we can take this on the other side there. What basically we are going to have, so we have 1 over 2 as a coefficient, then we have log 3 then x. So this part is basically equivalent to what? It's equivalent to the value of y. So we have 1 over 2 y. Okay, so we simplified. It's showing. We can also just say it's basically just y over 2. So we simplified both questions. So we can even show that at that stage. What we basically have is y over 2. Okay, then the last part of the question says, okay, and so otherwise solve 2 log that minus that is equal to 2. So what we have is we have 2 log base 3, then we have x over 9 minus log 3 root of x is equal to 2. Okay, so at this point, at least we know what this is equivalent to. This is equivalent to y minus 2. Then this is equivalent to what? This is basically equivalent to y over 2. Okay, so we can plug in there. So the equation that is going to come out is going to be 2. So this part is going to be equal to y minus 2. Let me just okay, let's do this to create some space. So this is equivalent to y minus 2, and this other part is equivalent to y over 2. Okay, so I can now erase what is on top here. Okay, so for the first part we are saying it's basically going to be 2, then this part is going to be y minus 2. Then as you get to look at this other part, minus, it's basically y over 2. So this is equal to 2. Just try to simplify it now. So we have a simple equation that is easier to work with. So as you get to open the brackets for the first part, what do we get to have? So we have 2y minus 4, then minus y over 2 is equal to 2. So we don't want to say fraction, we can multiply by 2 throughout. So multiply the entire equation by 2. So we have 4y minus 8 minus y then equal to a 4. So at this point, 4y minus y, those are like terms, so it's 3y. Then 8 can go the other side, so 4 plus 8. So our 3y is equal to 4 plus 8 is a 12. So our value of y is equal to 4. So we found the value of y. Are we done? No. Okay, let's do this. So we now know that our value of y is basically equal to a 4. Let's try to attempt to find the value of x, knowing that our y is basically equivalent to log 3 then x. So we have, where there is y, we can put what? A 4. So we have 4 is equal to log 3x. So there is another logarithm rule that chooses to say that this can go the other side there. 3 to the power 4 is equal to x. So therefore our x is equivalent to what? 3 to the power 4 is what? It's basically 81. So our value of x is equal to 81. So we've solved this question. So basically what I'm working with to simplify the questions that I have are basically the laws of logarithms. And if you've not done that, make sure you watch the video on that. Alright, so find the exact value of x for which 2 log base 10 x minus 2 is equal to a 0. Okay, so I'll copy that equation. So what we have is 2 log 10 x minus 2 minus log 10 x plus 5 is equal to 0. So in this case, it is a requirement that we find the values of x. Okay, what do we do? So we want to do away with the log so that we just remain with x. So since these are the same bases, we can take the other on the other side. So we would basically, we're going to have, okay, so as much as I want to do away with the logs, I would also want to do away with the coefficients. So what do we have? So what we have is, I'll say log 10, then I have x minus 2. So this one can become the power. It's a logarithm rule that if you have something like this, example log ba the power 9, that 9 can come here, it can also go back. Okay, so then minus, or basically we're saying that the other side, let this one go the other side, it will become a positive log 10 then x plus 5. So we can clearly see that, okay, the logs are the same. We can divide, they'll cancel out. Okay, so we basically have, so x minus 2 to the power 2 it basically means this equal to x plus 5. So what do we have? X times x is x squared, x times minus 2 is a minus 2, so it will be repeated twice, it will become a minus 4x. Negative 2 by negative 2 is a 4, equal to x plus 5. Okay, we can move. So we have x squared minus 4x. So this x can go the other side, it will become minus x plus 4. Then 5 can go, it will become minus 5. So we have x squared minus 5x minus 1 equal to 0. So what we have is a quadratic function that we can solve. So the product there is a minus 1. Factors, we have a minus, oh, for the sum, it's a middle part, which is basically a minus 5. Okay, I'll show that. So what values can we multiply to give us negative 1? Then when we add them, they give us a minus 5. Okay, so it's basically not going to come out. So let's work with a quadratic formula. So we have a negative of b plus or minus, our b squared is a minus 5 squared minus 4. Our a is what? Our a is 1. Our c is a minus 1. Divided by what? Divided by 2a. Our a is 1. Okay, so at that point we have 5 plus or minus roots of, so 5 squared there minus 4 times the negative 1, so we have 29. So root of 29 over 2. So at that point you can find the values of x. So one will be 5 plus root of 29 over a 2. Then the other one is going to be 5 minus root of 29 over a 2. So you can use your calculator to simplify that. Okay. So we can move to the second part of the question. The second part of the question says, given that log p base p 4y plus 1 minus log p 2y minus 2 is equal to 1. Express y in terms of p. How do you get to approach that question? So we're expressing y in terms of p. So we're kind of trying to make y the subject of a formula. Okay, so how do you get to approach such a question? So in this case, we can't take this on the other side because there's a constant, so there's no way we're going to divide it out. So the basic idea is to combine the log, and we maintain since the base is the same, then whenever you're subtracting we can divide these. So we have 4y plus 1 over 2y minus 2. So we've combined the log, that's the logarithm row, equal to 1. At this point this base can go the other side and it will become the base value. So we have 4y plus 1 over 2y minus 2 is equal to p to the power 1. So it will just be p. Okay. So now what is the question asking us to say? The question is asking us to express y in terms of p and not p in terms of y. So we are required to make y the subject of a formula. So if we cross and multiply, we have 4y plus 1 equal to, this p is multiplying with that. Then at that point you have 4y plus 1 is equal to, so this is going to be 2py minus 2p. So our goal is to make y the subject. What can we do? So correct the y to the left, so we have 4y minus 2py is equal to, so we'll maintain the minus 2p, then the negative 1 will come. So we can factorize our y. So what will remain is we have a 4 minus 2p equal to negative 2p minus 1. So in such a case, making a y the subject of formula, we have negative 2p minus 1 over what? Over 4 minus 2p. That's what we have as our value there. Okay, so we've expressed y in terms of p. Okay. Question C. Show that the equation, so the equation that we have is 2 log base 2 y is equal to 5 minus log base 2x. So the question is saying show that it may be written in the form of, so I'll copy that form. It's basically y squared is equal to k over x. So how do you get to do that? So I'll start. So we have 2 log 2 y, then I can take this on the other side because there's a constant there, so it will be plus, then we have log 2, then x is equal to 5. What would we do? We'd want, before we get to combine the logs, let that one become the power of a y. So we have log 2, then y to the power 2 plus log 2, x is equal to 5. Okay, so if you're still lost with your logarithm laws, make sure you watch the video. Okay, so we now have log. We can combine the logs now since the base is the same. And what are we doing? We are adding, so we can multiply the values. So we have y squared being multiplied with the x being equal to 5 on the other side. Okay, I'll draw a line here. Now continue from there. Okay, so we now have, so these 2 can shift to the other side and it will become the base. 5 will become the power. So we have y squared multiplied by x is equal to 2 to the power 5. At that point, y squared is equal to 2 to the power 5 is what? So 2 to the power 5 is basically 32. So we have 32, you divide by x. So we've shown in that form, it's basically y squared being equal to k over x. So where they are saying where k is a constant to be found. So we found the value our k is basically equal to 32. And we've expressed it in the required form. Okay, so the question follows to say, hence or otherwise, solve the simultaneous equations given below there. So we have some simultaneous equations shown. How do you get to simplify them? So if you look at the first simultaneous equations, it's basically equivalent to the equation that we are just from simplifying. And the simplified form of it is we are saying is y squared is equal to 32 over x. Okay, so we can go to the second equation then. Where is the second equation? The second equation says log xy is basically what? Equal to, okay, let me show that down. Okay, log xy is equal to a minus 3. That's the second equation that we have. So we now know our value of what? We now know our value of y. So what value of y do we have? So making y to be the subject in this first equation, y is going to be the root of what? 32 over x. Okay. Now that we have the actual value of so let me erase there, we see some space that we're going to work with. Okay. Then let me write this on top, or let me just move it to the top part so that we have enough space down there. Okay. So what are we saying? So we can plug in now. So we have log x. So I have is y. We can put now so the square root is the same as raising what you have, the power what? Raising what you have the power 1 over 2 equal to negative 3. So is there any way this can be easily worked around with? Okay, so what do we do? What we can do in this case, we would want to deal away with the x. How do we get to go about it? So this x can go the other side and it will become the power there. It will become the base. So this is going to simplify to 32 over x raised to the power of 1 over 2 is equal to the other side. What do you have? Okay, so this is x there. So this x is going the other side, it will become the base. So it's x, then to the power what? Negative 3. Let's try to move. Okay, so we have x 32 over x raised to the power 1 over 2, then we have x being equal to the power of negative 3. So since we have a negative power, what can we do about it? So let's try to multiply the entire thing by the power 2 on both sides. Just square both sides. We square both sides. So we square. So if you square where we have 1 over 2, multiply by 2, then where is a 3, we multiply by 2 as well. Okay. So that we do away with the half. So basically what we have is we have 32 over x equal to the other side. We now have x the power negative 6. Okay. So how basically do we get to find the value of x in this case? Okay, so what happens if you get to cross and multiply? So if you cross and multiply, you basically have 32 being equal to x the power minus 6 being multiplied by x the power 1. So from the laws of the indices there, when you have the same base there and you're multiplying, you get to add the powers. So this is going to be 32 x the power minus 5. Okay, so we don't want the power of a negative there. How do you get to approach a question there? We don't want the negative power. So you can find the reciprocal on both sides. So The moment you find a reciprocal, so it's going to be 1 over 32. Then the power will become positive. So we found the reciprocal on both sides. Okay. Or the other way of approaching this question, in case if you don't understand what I'm saying. So what we're trying to say is 32 is equal to, so if you want the power to be positive, you can take the x to be a denominator there, to become power 5. And if you try to make x to the power 5 a subject, it will be 1 over 32, which is basically the same. So at this point, finding the value of x is going to require us to find the 5th root of what? 1 over 32. So what number can you multiply 5 times to give you 32? So it's basically 2, because 2 times 2 times 2 times 2 is going to give us what? A 32. So we found the value of x to be 2. So now that we have a value of x being equal to 2, how do you get to find the value of y? Remember, we know that our y squared is equal to 32 over x. So if you can plug in there, y squared is going to be 32 over 2. So 32 divided by 2 is going to be a 16. Then the square root of 16. So the two possible values of y are, so okay, there was a condition to say the values of x are supposed to be, values of y are supposed to be greater than 0, so it will just consider a positive result. So for the root of 16, we just consider positive 4 as our value of y. And that means that we've solved the simultaneous equation there. Okay. D. Find the y for which 4 that is equal to that, giving your answer to 4 significant figures. Solve giving an exact answer to the equation. So these are two different questions. Starting with the first part, what do we have? So we have 4 being raised to the power of 3y plus 2 equal to 3 raised to the power 600. So this requires you to understand the concept of the logs for the exponentials, where you can't maintain the same base, where you can't make the base to be the same. Obviously, we understand when you have 2 to the power 3, for example, or let's say 2 to the power x being equated to 8. In such a case, it's possible for you to come up with the same base, where you just say 2 to the power 3, then you're able to find the value of x like that. But in this case, it's impossible. So you get to work with logs. So in terms of logs, what we get to do is, the moment you introduce a log on both sides, so we introduce a log on both sides, and we know that there's a lot of logarithms which can take the power to the left to be the coefficient. So for the first part, we have 3y plus 2 being dropped as the coefficient of the log. Then the other side, we also have the same, or the 600 can also be dropped, then log 3. So what is our goal? Our goal is to find the value of y. So it wants to make it to be a subject. So we have 3y plus 2, then we can divide by log 4 on both sides, over log 4. So at this point, we can also move. So trying to make y the subject, 3y, the 2 can go the other side, so you have 600 log 3. Okay, 600 log 3 over what? Over log 4. So we can subtract the 2. Then what else do we need? We need to divide by a 3 throughout. So if you divide by a 3, the 3 will disappear there. You divide by 3, you divide by 3. So using your calculator there, so 600 log 3, so 600 then log of 3 divided by 3 log of what? Log of 4 minus 2 over 3. This is basically going to give us a value of 157. So we have 157.8. That's the value of y there in such a case. So that's it for the first part of the question. It just requires you to move from exponentials to the logs. Then the second part of the question says solve giving an exact answer the equation. So we have another equation. It's basically log of 2 base 2 x minus log base 2 2x plus 4 is equal to a 4. So that's what we have. Solve giving an exact answer the equation that minus that being equal to 4. You should show each step in your working. So in this case we have the same base there. We can maintain the base. So we have log of 2. Then when you're subtracting, we are saying if you've maintained the base, you can divide. So we are adding x plus 3 being divided by 2x plus what? Plus 4. So that's the logarithm row. Then equal to 4. At this point, you can move this to the other side. So it will become the base. So we have x plus 3 over 2x plus 4 being equal to the power 4. Okay, we can move there. We'll see what we're going to have. So we now have, so 2 to the power 4 is basically what? So 2 to the power 4 is basically a 16. So we have x plus 3 over 2x plus 4 being equal to 16. So we can cross and multiply there. So we have x plus 3, then we have the other side 16, 2x plus 4. So we'll maintain x plus 3. 16 by 2 is 32 x. 16 by 4 is 64. Okay, so I want to find the value of x there. What should we do? So I can correct the like terms. So we have x minus 32x equal to 64 minus 3. So x minus 32 is a minus 30. Minus 31x being equal to 64 minus 3 is 61. 61 divided by 31. Okay. So let's do this. So our value of x is basically going to be negative 1.96 or 97. Okay. Okay, so for the last question, find the values of x for which log 5, so log base 5, x plus 6 log base x5 is equal to 5. So that is the question that we have in this case. So how do you get to approach it? Okay, so in this case, this question is different from the questions that we've looked at because of the bases. The bases in this case are different. So I'd want to make sure that the bases are the same. Okay, so you can pick whatever you want. For me, in this case, I would rather make x to be the the base. So I'll change the base for this one. And how do you get to change the base? So we have log base 5 x. So to change the base, write the new logs being divided with the new base. So let's say the base will be x. So write it down as well. So the numerator part is going to be covered with what? It's going to be covered with x. So we have x. Then the denominator is going to have a 5. So for the top part, since we have the same base there, so this is equivalent to a 1 over, we have log x base 5, log base x5. So that is actually what that is equivalent to after changing the base. So we have 1 over log x5. So we can write that. So for first part we have 1 over log base x5 plus 6 log base x5 is equal to 5. Okay, so in this case it's kind of cumbersome to you just work it direct the way it is. So it's better you write this part, since it's the same, to be equivalent to a certain variable. Alright. So maybe let's say y is equal to log base x then 5. So we have 1 over y plus 6y is equal to 5. Okay. Then at that point we'd want to make y the subject, so we multiply the entire equation by y squared, so I have to try to find the value of y. or we multiply by y, sorry. So the first part, the fraction will be delta y, it will just be a 1. The second part will be 6y squared. Then the other part you have what? You have 5y. So coming up with a standard quadratic function, this is going to be 6y squared minus 5y minus or plus 1 is equal to a 0. Okay, so you can pause the video and solve that equation quadratically. So you have 6, your a in this case is 6. Okay, so how is it going to come out in such a case? Okay, so let me show that. For our products, we have a 6. For our sum, we have a negative 5. What values can you multiply to give you a 6? You add them, they give you a minus 5. Okay, so is it possible? Think of 6, negative 1. Not possible. So let's try to work with a quadratic formula. So we have our y being equal to the negative b plus or minus the root of b squared. Our b squared, our b in this case is what? It's negative 5 squared. So minus 4, our a is 6, our c is 1 over 2a. Okay, other points, what can we do? So our a, our a is a 6. So we have 5 plus or minus 5 squared is 25 minus 4 by 6 is what? 4 by 6 is 24 over, so we're supposed to divide by what? So divided by 2 by 6, which is basically a 12. Okay, so over 12, so the root of that. So at this point we have 5 plus or minus 25 minus 24 is a 1, so it will be a 1 over 12. So the possible values of our y is, first part, 5 plus 1 is a 6 over 12. The other possibility is 5 minus 1, which is a minus 4 over a 12. So these are two different fractions that we're going to have. So these are the two possible values of y. So 6 over 12, that is a fraction that can reduce to 1 over 2. Then the other one is negative 1/3. So these are the two possible values that we have of y. Okay, at that sense, so we say that let our y basically be equivalent to what? So what did we have after changing the base? So after changing the base, what we had is basically, we said log x 5. So that's what we had as our value of y. So now let's equate it with the values that we have. So for the first part, I'll say, okay, let my y be equal to 1 over 2, being equal to log x 5. So trying to make x the subject there, how is it going to come out? So we can therefore say, okay, x can go the other side, so it will be x to the power 1 over 2 being equal to 5. So our first possible value of x is 5 what? Is going to be, so you get to multiply by, so in this case we have 1 over 2, so we can square on both sides instead. So the power 2, the power 2. So therefore our possible value of x is going to be 25 for the first part. Then the other part, what do we have? So for the other part, we're going to say, okay, our y is negative 1 over 3 being equal to log x 5. What do we do in this case? So we have, so x can go the other side, it will be x to the power negative 1/3 being equal to 5. Okay, then at that point what you get to do, so you want to multiply, you would want to raise it to the power what? Cubed in this case. So it being raised to the power 1 over 3, I would want to work with a positive power. How do we get to approach it? Let's do this. Okay, so we'll say, okay, in such a case, let's make it the reciprocal so that things change. So it will be 1 over x to the power positive 1 over 3 being equal to, the other side it will be 1 over 5. Okay. So that's what we have in this case. So how do you get to approach it now from that point of view? You want to find now the exact value of x. So since what you have on top, so you have x raised to the power 1 over 3 being equal to what? Being equal to 5. So for you to find there, you need to raise this to the power 3, and therefore x is going to be what? 5 times 5 times 5 times 5, which is basically 5 to the power 3. 5 to the power 3 is basically what? 125. So we found the values, the possible values of x in that case. And that's it for this video. Thank you very much for watching.